again. It's a redskin.
So in our previous video, we have discussed about functions in Python. Like to define a function, we need to use this def keyword, and then we need to give the function name. In our case, it is myfun, and then we pass the formal argument. In this video, we are trying to understand how this formal argument and this actual argument that we pass while calling the function are linked with each other. So let's understand the execution of this program. So after executing this program, this line will execute first because a function will not execute until we call it. So this block will not execute. So first of all, this a equals to 50 will execute. So object with value 50 will create in the memory like 50, and this name a will point to this memory location like this, and this object will have a memory address. So let's take 3000 as this address, and in the next line we are calling this function like myfun, and then we are passing the actual argument that is a. Actually we are passing the object reference that is 3000 in this function. So now onwards x also will point to this location that is 50, and you can also verify it by printing the id of this x inside this function and also the id of this actual parameter that is a. So let's execute this program in IDLE. So this is the program, and let me execute this code. Now here note that the formal argument that is x are pointing to this location, and this actual argument also pointing to the same location. So here x and a are pointing to the same location. Now my question is, what will happen if we change the value of this formal arguments inside this code, inside this function? Like if I change it from 50 to 100, so what will happen? So let me first print it like formal argument, and then I'm trying to print the value of x and then the location that is id of x. And here also let me print it after execution of this function. I'm trying to print the value of a here, and then I'm also trying to print the address like this. And here another point is, don't think that it is a local variable, because x is formal argument. So x equals to 100 is not a local variable. Like you can create a local variable like y equals to 100. It is valid, it is a local variable, but x equals to 100 is not a local variable. It is the formal argument that we pass here while defining the function. So x equals to 100 is not the local variable. So what will happen? Let me execute this code first. Now here note that the formal argument, the value of the formal argument is 100, and it is pointing to this memory location, and the value of the actual argument remains same, that is 50, and it's pointing to this memory location. And here note that these two locations are different. So as soon as we change the value of this formal argument in this function, then this both formal argument and this actual argument are pointing to the different memory location with different value. So from this we can conclude that if we change the value of the formal argument inside this function, then it is going to point to the different memory location. And this is valid for all the immutable data types. Like if we have a float value like 50.50, or if we have a string value like string like this. So we can conclude that if we change the value of the formal argument, then it will not affect our actual argument, but it is applicable for the immutable data type. But what if we pass a mutable data type like a list? So let me pass here a list like 1, 2, 3, and then in this function I'm going to change the value of this list. Like I'm going to append one more value like x dot append 4. So now we will see what will happen. So let me execute this code. So here note that the formal argument is pointing to this memory location and our actual argument is also pointing to the same memory location. And after changing the value of this formal argument inside this function from 123 to 1234, our actual argument has also changed from 123 to 1234. So we can conclude that if we pass a mutable data type like list or set, and then if we change the value of that list or set inside this function, then our original value or the actual parameter also change. So our next topic is different type of arguments. So here we have declared a function like def square of x. Here note that in this parenthesis we have passed one formal argument. So while calling the function, we need to pass that amount of actual argument. Like here we have passed one formal argument, so here we need to pass one actual argument. Like if I pass here x comma y, that is two formal argument, then here also we need to pass two formal argument like this. So if I pass here 5, and then it will return the square of 5, that is 25, and let me store it in a, and then I'm going to print it like this. So let me execute this code first. So it is showing 25. But here note that if I don't pass anything while calling this function, it will raise an error like this. Missing one required positional argument x. So it is mandatory to pass the same amount of actual argument that we pass while defining the function as formal argument. So if we pass two formal arguments, then while calling the function, we need to pass here two actual argument. Otherwise, it will raise an error. So these arguments are known as required arguments. As far as the required arguments are concerned, these are the arguments which are required to be passed at the time of function calling. Otherwise, it will raise an error. So our next topic is default arguments. Python allows us to initialize the arguments at the time of function definition. Like here, if this function takes two formal arguments like x comma y, and then it will return x plus y. So if I pass here only 5, then it will raise an error because here we have passed two formal arguments. So here also we need to pass two actual argument. But if I initialize this y with default value like 10, then it will not going to raise an error, because if I pass here 5 comma 6, then the value of y will be 6. But if I don't pass anything, then the value of y will be 10. That is the default one. So let me first pass here 5 comma 6, which will print 11. So let me execute this code. So it is showing 11. But if I don't pass anything while calling this function, if I pass only the value of x, then it is going to add this 5 with this default value, that is default value of y, that is 10, and it will print 15 like this. So this is all about default arguments. So our next type of arguments is variable length arguments. In a large project, sometimes we may not know the number of arguments to be passed in advance. In such cases, Python provides us the flexibility to offer the comma separated values which are internally treated as tuple at the function call. By using the variable length arguments, we can pass any number of value. So to do that, we need to first give a star, and then we need to give the tuple name. So because the elements that we pass while calling the function will be treated as a tuple internally. So let me give a name t, and then while calling the function we can pass any number of values like this, and then here I am trying to print the sum of all this element. So let me initialize s like this, and then add all the values like s equals to s plus I, and then return s. So let me execute this code. So it is showing 39 because the sum of these elements is 39. So our last type of arguments is keyword arguments. Python allows us to call the functions with the keyword arguments. This kind of function call will enable us to pass the arguments in the random order. Like here in this function, we need to pass two arguments, and I have considered the first argument as the integer value and the second argument as the string value. And now if I call the function with these values like first integer and then string, then it will works fine. Like if I execute this code, So here note that the integer value is 50 and the string value is string. But if I pass these arguments in reverse order like this, and then if I execute this code, so here note that in place of integer it is showing the string value. So in this type of cases we can use this keyword arguments. Like to pass an argument we need to use the keywords. Like here I have considered y as the string value, so here we need to write y equals to string, and then here I have considered x as the integer value, so here I need to pass x equals to 50, then it will work fine. Like this, the integer value is 50 and the string value is string. So our next topic is lambda function. Python lambda function is known as the anonymous function that is defined without a name. Python allows us not to declare the function in the standard manner, that is by using def keyword. Rather, the anonymous functions are declared by using the lambda keyword. So to declare a lambda function we need to write lambda, and then it can take any number of arguments like x, y, z, and then we need to give colon, and then we can write only one expression like x plus y plus z. So it will return the sum of this x plus y plus z, and it will return the sum, so we need to store it in another variable like s equals to this, and then we can call this function by using s, like print the sum is comma then s, and within parentheses we can pass the numbers like 1 2 3 like this. Let me execute this code. So it is showing the sum is 6. So here note that we need to call this lambda function by passing the values like this way, like a's of 1 2 3. So our next concept is immediately invoked function expression. In this type we need not to call this lambda function explicitly. Like if I write lambda and then x y z and then x plus y plus z, in the same line we can pass the values like this way, and then let me print this total thing like print, and let me execute this code. So here note that it is showing 6. So this is known as immediately invoked function expression.